So we're just going to go through the routine right now of, figuring out how to lay down the synthetic division statement basically, and go ahead and doing the synthetic division with something fairly simple, okay? And, watching out for expressions like this where your constant in front of the x is not just 1. When you get an expression like this, if they ask you to do synthetic division, this is what you're going to have to end up doing. You take the numbers, the coefficients in front of the x terms, and the constant back here. So you take all the numbers, you forget about the x's, right? You forget about the variables. You take all the numbers and you lay them down, okay? And you do a sort of an upside down root symbol or upside down division symbol. And what you have to do with this guy is you're going to have to set this equal to 0 and move it over so it's x equals whatever the number is, which is going to be -1/3. And we're going to take all the coefficients and lay them down here and, set up our synthetic division statement and go ahead and start doing the synthetic division. So what we do is set -3x plus 1, or minus 1 is equal to 0, bring the 1 over, and then divide by -3. So what we have is x is equal to -1/3. You take this guy and you move it up there. You lay down and this is your synthetic division statement. This is the way you lay out your problem, okay? You do sort of an upside down division symbol, just a, semi box or half of a box, right? You take all the numbers in your numerator, right? In what you have in the fraction up top, and you put them all down there, okay? Now keep in mind, the sign in front of the numbers, always go with the numbers, and if you have any missing x terms, you have to put a place marker there, right? So if this was -3x squared plus 5, that would have been, if you were missing the middle term, the x term, you would have had to put a 0 instead of the 5 here, because you need your polynomials, your numerators, to be in descending order, first of all, and you need them to be in order. So if you have, x to the power of 5, the next one has to be x to the power of 4, x to the power of 3, x to the power of 2, x to the power of 1, and your constant term. If you're missing any of the powers, any of the terms, you're going to have to put a 0 marker there. Okay, and we'll do a couple of examples that way where you see what the place markers are. Right now, we're not missing any terms. It's all in descending order, and we don't have to put any place markers. So you take all the numbers, you lay them down there. This is the way synthetic division works. You're going to take the first number, the one in the coefficient in front, the highest power, and you're going to put it down here. This number here, so it's -3 is going to come down here. -3 is going to multiply this guy. So this guy here multiplies all the terms, and the multiplication result goes up here, and you add up these terms here, and that comes here, and you continue to do the same thing. So basically, the motion that you're going through is this guy coming down, going like this. So it's a sort of a zigzag. Ding, 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 ding. So what we do is the -3 comes down. -3 times -1/3 goes up there. Now -1/3 times -3 is going to be +1. 5 plus 1 is going to be 6. -1/3 times 6, that's going to go up there. Now -1/3 times 6 is going to be -2. And we put that there, and 2 minus 2 is just going to be 0. So what that means is that guy is a factor of that guy because our remainder is 0. Our remainder is 0. That means if we sub in x is equal to -1/3 for all the x's in the numerator, the answer is going to equal 0, which means this guy is an x-intercept. That's where it crosses the x-axis. That's where y is equal to 0. Now we've talked a lot about this, doing the doing the polynomial long division, and doing the factoring stuff, right? So this should be fairly familiar to you. Just doing a little quick recap. Okay. So what ends up happening if we think about the polynomial long division? Our terminology. This guy is our d of x, right? It's our divisor, right? This guy up here is our dividend, is our product, is p of x. That guy up there, right, is our polynomial. This guy is our remainder. Whatever ends up being the last term in the synthetic division, right? That's going to be our remainder. Right now our remainder is equal to 0. And these guys, negative 3 and 6, that's our quotient. And the way it works is, right now, we took an x to the power of 2 and divided an x into it, right? That means we've reduced this power by 1x. So this guy becomes negative 3x plus 6. If this guy was x to the power of 5 in the top, and we're dividing an x into it, this term would have been negative 3x to the power of 4. So every time you do a synthetic division, every time you divide an x into the top, what it does, it kicks down the power by 1 order. And all you do is, these numbers here, no matter how many you get, all they are, you start off with the next order, descending order, right? So if that was an x to the power 5, the first one would be x to the power 4, and then x to the power 3, x to the power 2, x to the power 1, x to the power of 0, which is your constant, right? Right now, this one, we started off with x to the power of 2, divided an x, so that just means there's an x here, right? So it's negative 3x plus 6. This becomes our quotient. What this means is if you brought the negative 3, negative 1 over 3 over, this would be x plus 1 over 3. So if you multiplied x plus 1 over 3 by this guy, you would get your original polynomial. If you multiplied negative 3x plus 6 by x plus 1 over 3, you would get back our original polynomial, right? Here's the problem when you're doing synthetic division, when the number in front of the x is not 1, but some other number. Now, we got this quotient out. We got this result out with a remainder of 0. This is the problem. If we took this guy and multiplied it by negative 3x plus 6, we wouldn't get that guy up there. Because negative 3x times negative 3x is going to be 9x squared, which obviously is not what's in the top. So this is what you really have to watch out for whenever you're doing synthetic division, when a number in front of the x is not 1. When you do this division, you might end up with a quotient that, if you multiply that quotient with your original expression here, you're not going to get the top guy. Because, we ended up manipulating this guy to get an x is equal to negative 1 over 3, right? We moved everything over, so our a term, when we set up the, when we talked about, what we're going to use synthetic division for, our a term is now a fraction. If you took this guy and multiplied by this, yes, you're going to get the numerator. If you took this guy and multiplied by this, you're not going to get the numerator. When you get something like this, you have to visually check to see if you multiply this by this, if you're going to get that guy, okay? And if you realize that this guy times this guy doesn't give you the top guy, take a look at this guy and take out a GCF. And you're going to have to make a decision of taking out something that's going to convert this to an expression where if you multiply it by what you had in the denominator, it's going to give you the original expression. So there's two different ways, and actually there's multiple different ways you can think about this and do the corrections necessary to present your answer, the correct answer, if you're asked to do polynomial long division like this, or when you want to factor large polynomials of higher degree than degree of 2, and polynomials that are bigger than just simple trinomials, anything that has more terms than 3 terms. Basically, the two different methods that you can think about in presenting the right answer, getting the right answer after you do your synthetic division are the following. The first one is, all you got to do is look at the number in front of the x when it's not a 1, take this number and divide your quotient by this number. So the first way you can do this is the following. You can take negative 3x plus 6 and divide it by negative 3. And what happens is, if you take out a GCF from the top, it's going to be, well, the GCF that you need to get rid of your negative 3, right? You could take out a 3 from this, but what you would end up is, you would have you would have negative x plus 2, and there's going to be a 3 up front, and that's not going to get rid of your negative 3 in the bottom. So what you're going to do is sort of a decision that you're going to have to make, right? And there's a lot of decisions that you can make when you're doing mathematics, when you're doing simple, simplification, you're running through algorithms that make your life easier. And the more you do, the easier it gets, right? So initially, if you take out the wrong thing, don't worry. What's going to happen is you're going to have to take out another factor to get rid of whatever's going to be left in the denominator. But the more of these you do, the better at it you're going to be, okay? So right now, we have a negative 3 in the denominator because that was our b term, whatever our coefficient in front of the x, right? So what we're going to do is take out a negative 3 from here. So this turns out to be negative 3 comes out. And if you take out a negative 3 from negative 3x, it becomes x. And if you take out a negative 3 from positive 6, it becomes negative 2. So negative 3 up top can kill negative 3 in the bottom. So this guy kills this guy. So your final answer for your quotient, when you take this polynomial and divide it by this polynomial, is going to be x minus 2. Right? And that's the first way you can think about it. The second thing you can do is take a look at what we have here. It's x plus 1 over 3. Then what you can do is take out a GCF from this and just take that GCF and multiply it with this guy, which is really the same thing that we did here, but it's just another way of thinking about it. So what you can do is the following. You can take negative 3x plus 6 and take a look at this guy. And you know there's a 3 in the denominator here, right? So you want to get rid of that 3. And what you're going to do is GCF out the largest thing possible. And in general, for the quotients, you want the x term, or for terms like this, if you can get this guy, the x, to be positive, then that's what you want to do, right? So you're going to take out a negative 3x. And again, that comes out to a sort of a decision that you're going to have to end up making. Because if you only take out a 3 and multiply it by this guy, the 3 is going to come out here and multiply this guy, and that's going to be 3x plus 1. But that's not what we had in the denominator here. So you're going to have to go back and factor out a negative 1 and redo the thing. So again, the more of these things you do, the better you're going to become at it. So it's a decision that you're going to have to make, right? So you're going to have to look at this guy and say, this is what you want to get out from this guy, because this is really what you're dividing that guy with, right? So if that's negative 3x minus 1, what you want this guy to be is negative 3 here. So what you're going to do is take out a negative 3 from this guy. So what ends up happening is you have your quotient. You got negative 3x plus 6. And this guy times this guy times this guy gives you your original polynomial. But this guy doesn't appear here anywhere, right? So what you're going to do is try to convert this into this. And the way you're going to do it is you're going to factor out, GCF out, a negative 3 from this. So you factor out a negative 3 from this guy. That's going to be negative 3 coming out of this. Again, it's going to be x. Negative 3 coming out of this. Again, it's going to be x. And negative 3 coming out of 6 is going to be negative 2. And then what you're going to do is going to take this guy, and multiply it inside this expression. And what's going to happen is you're going to get x minus 2. And negative 3 times x is going to be negative 3, negative 3x. And negative 3 times 1 over 3 is going to be negative 1. And now, this expression is equivalent to this expression. And this guy times this guy would give you your numerator up top there. And to write your answer for this, if this was straight out division, this divided by this, your answer would be x minus 2. X minus 2. It would not be this guy, because this guy times that guy does not give you that. Okay? Watch out for these types of questions. Be careful with these. You might get them.